Okay, welcome. Today we're going to look at solving trigonometric equations. This is chapter 5.3 in your text. So let's go ahead and take our notes out and get ready to go. Remember, during the video, if you feel like you are falling behind with your notes, make sure you pause the video and get caught back up. And if you did not quite understand something the first time, pause the video, rewind it, and listen to that section again. Sometimes it takes a couple of times through to understand the concept. Okay, here's our objective for the day. Our objective in part 1 will be students will solve trigonometric equations with one trig function using inverse properties. All right, here's our first example. We're going to solve and check it using a graphing utility. We're going to solve 2 secant x minus 4 is equal to 0. So let's go ahead and write that problem down. Again, that's 2 secant x minus 4 is equal to 0. Now the first thing we want to do to get at the answer is to isolate the trig function. And we're going to do that using inverse properties. So to isolate secant x, we're first going to add 4 to both sides. And that will leave us 2 secant x is equal to positive 4. And then we're going to divide both sides by 2. And that will leave us secant x is equal to 2. All right, to isolate our trig function, it's done basically the same way as solving a linear equation. We're just using our inverse properties. Now that our trig function is isolated, we can now look at solving for the actual value of x. Now realize the value of x is going to be an angle. Okay, to go ahead and find the angle, we're going to need the use of our unit circles. So let's go ahead and pause the video and pull out our unit circles. Okay, now that we have our unit circles out, let's go ahead and find our angle. What we're looking for is the angle, or angles. When I take the secant of those angles, I get positive 2. Now in its current form, that's going to be a little bit hard to see, so we're going to do a little manipulation. I know that secant is the reciprocal of cosine. So using our properties, we can say secant is the same as 1 over cosine x. And I can say that's still equal to 2. Now if I take the reciprocal of both sides, I get cosine x is equal to the reciprocal 2, which is 1/2. Now we're going to go ahead and look at our unit circles and find all the angles that when I take the cosine, I get 1/2. Okay, now we're going to use our unit circle to identify everywhere cosine is positive 1/2. So starting in quadrant 1, I can see that cosine, or my x value, is positive 1/2 at pi over 3. Jumping to quadrant 2, I can see that all my cosines, or x values, are negatives, so there will be no solution over here. The same thing applies in quadrant 3. All my cosines are negative, so there's going to be no positive 1/2 over here. And then lastly, in quadrant 4, I know cosine, or my x values, are positive again, so cosine is positive 1/2 at 5 pi over 3. Okay, now that we found our two solutions, the angles pi over 3 and 5 pi over 3, we have to remember that trig functions are periodic, and therefore we're going to have infinite solutions. So I opened up Desmos and I graphed the left side of the equation, 2 secant x minus 4. The right side of the equation was 0, so that's just the x-axis. I'm going to look for points of intersection with the x-axis, or our intercepts. So right away we can see that my first point, or our solution we found, I should say, is pi over 3, and it sits right here, point of intersection. And our other one was 5 pi over 3. Now, because secant, along with cosine, have a period of 2 pi, our solutions should be 2 pi apart, and we can see that in the graph. If I go 2 pi to the right of pi over 3, I end up at 7 pi over 3, and I could keep going. If I go another 2 pi, Now this one's off the screen, but it would be that point right there. Now I can do the same thing to the left. If I go 2 pi to the left in the negative side, I can see that's going to land about negative 5 pi over 3, and that would be a solution as well. If I look at 5 pi over 3, again, 2 pi apart, and go 2 pi to the right, I end up at 11 pi over 3. And if I go 2 pi to the left, I end up at, let's draw the line in there, negative pi over 3, and I can do one more time, and negative 7 pi over 3. So those are just a few of the infinite solutions. The key is they're all 2 pi apart. Okay, now we have to represent all infinity answers, and we're going to do this by using or writing what we call the general solution. We start by taking our two answers, which was pi over 3, and our other one was 5 pi over 3. And remember, these are our answers that were within one revolution of our unit circle, which means they were in the same period. Now, to get to our other answers, or represent our other answers, we're simply going to add the expression 2 pi n to both our angles. Now, all this means, or the n represents the number of 2 pi's we're going to add or subtract from pi over 3, and the number of 2 pi's we're going to add or subtract from pi over 3. From this expression, by placing values or integers in for n, we can get every other answer for 2 secant x minus 4 is equal to 0. Okay, I hope that helps. If you have any questions, remember, write them down and ask me during class. Thank you.